Welcome class back to Chapter 8 Functions. This is the second video for Chapter 8. In this second video we're going to cover the middle sections, which is return values, making an argument optional, returning a dictionary, using a function with a while loop, passing a list, modifying a list in a function. Return values on page 137. So a function doesn't always have to display its output directly. Instead, it can take the data that was created in the function and then go ahead and return some sort of value or values back to the call statement. So we have a return keyword and we return the information back to the line that called the function. Allows you to move much of your program's work into the functions, therefore simplifying the body of your program. So let's look at an example of formatted name. Formatted name has a return statement. So the function name is getFormattedName. You'll notice it repeated here. This is the function call. So the function call sends along two arguments, Jimmy and Hendrix. Jimmy is going to be stored in our first name. Hendrix is going to be stored in our last name. We create a variable called full name, creating the string first name, space, then the last name, give it the title method to it, and then return that back. So when we return, we come right back down to the call, and that value is then stored in the variable that's on the left side. So with the return, you always need a variable on the left side to catch what we're returning back down to the call. And in this case, we're going to print out what was returned. So of course the value comes through as Jimmy Hendrix because we ran it through the title method, that we have that capital J and that capital H. Making an argument optional. So in our first video we talked about default values that we could set for a parameter. Well, now we're going to make that parameter or our argument optional. So in this case we have first name, last name, and then middle name, and not everyone may have a middle name. So in this case we have two examples where we call getFormattedName, one with just first and last, and then our second example we have first, last, and then we have a middle name. So let's go ahead and expand our example here to reflect this. So we're going to add in middle name, and that's going to be our optional. And actually we're going to put it right in the middle. And so we have our first example with Jimi Hendrix. I'm just going to go ahead and copy this, just I hasn't had it in my slide. It's not exact of what's on page 138, but we will change this to John. And I guess this is the middle name of Lee. And then we have Hooker as the last name. So here we need to incorporate the middle name into our output string, and a space in between each. So I'm going to comment this out for now just so that we don't create any errors because I don't have a middle name in that example. So now we have John for first name, John for first name, Lee for the middle name, and then Hooker for the last name, and again we just adjusted the output string. But what if we had the case where we had these two examples here, with one having the middle name and one not having the middle name? Well, we can throw in a if statement that will allow us to create the proper string to output back. So we're going to do if they have a middle name, and I'll adjust the optional value here in a second. Middle name is equal if middle name. So if they have a middle name, we're going to create this one here. Else we're just going to have without the middle name. Now to get that output to be correct, we're going to have to move middle name to the end and give it a default value of empty string. So now both of these statements should work correctly because we assume that they do not have a middle name, and if they do have a middle name, then this will be changed from that empty string. We do, however, need to change the order of our arguments in our call because middle name is now at the end. Let's see, what do I have here? Else. Forgot my colon. There we go. So our first output without the middle name and our second output with a middle name. So if there is a value, when we do this, remember in our discussions with the if statements, if we do have a value here, then this returns true. So that's why we jump into line 4. If we don't have a middle name, that's when we're going to go into the else side. Returning a dictionary. So if we have multiple values that we want to store with keys, we can certainly build a dictionary. And so in this case, we're building a dictionary with a key of first and the key of last, using our parameters of first name and last name as the values. So let's go ahead and look at person. So person has build person function. So we send along Jimmy and we send along Hendrix, stored in first name and last name. And again, the only difference here is we're building a dictionary instead of building just an output string. Where in formatted name, we were just building an output string to store in a variable. Okay. Here we're building those keys. And then we're going to go ahead and return that dictionary back down. It'll be stored inside of musician, and then musician will be outputted, which will be the output of a dictionary. So down here you'll see the curly braces, your keys and your values. Now let's further add in if they had an age. Okay, so we're going to add in age here, and instead of doing an empty string, since it's numeric, we're going to use the value of none. Okay, and then turn in an if statement just like we did with the middle. We are going to do, I'm going to leave this dictionary first. If age, so if we send along an age value, we're going to create a new key in the person dictionary of age, and we will store age there and then return person. So now if we add in an age of 27, we get the output of our new key. Okay, so if there is no age, let's try this. So an optional value, okay, just like we had with the string over here with middle name. So this is what you'll use if you're using an optional numeric value. Using a function with a while loop. Okay, so we will be, every time we iterate through the loop, in this case while this is true, we will be calling get formatted name. So let's go ahead and look at a new example, greeter.py, or I call it page 141. Okay, so we have the definition of a function, get formatted name, 2 parameters, first and last. Oh, and I got to update this up so that it is Python 3.7. So we just need to put out curly braces. There we go, we got our F string there. Okay, and then we'll use our loop to run through. Please tell me your name. And then we have this input. So now this one again, you're going to have to run through your terminal so that they can input their first name and their last name. Once they input, then we will call get formatted name, send the variables or the values that they entered in to the function, and then go ahead and return that information back down to the call on line 14, and then go ahead and print out formatted name. So let's go ahead and run this. I did that yesterday too, chapter 8. Okay, and I'm going to go directory listing on this so that I can see my files. And Python greeter page 141.py. Okay, so my name, my last name, and then it keeps prompting. Okay. So with it keeping prompting, that's one of our issues with this. So we're going to have to enter in something to go ahead and quit the program. Okay. So I'm going to just close my, let's see if I go Control D to get out of there. Nope. Infinite loop. So I'm just going to exit out of command prompt. I'll open this back up so I can go ahead and test again. Oh, it doesn't look like it cleared. There we go. Okay, so let's go ahead and modify. I hope I don't have a slide on that. So we'll go ahead and modify what's on bottom of page 141. So 141, we're just going to enter in the queue information. Oh. So print enter queue I have my quotes in the wrong spot there. So if fname equals q, then we're going to break. So we'll let them input. If fname is equal to q, we break. And now the same thing is going to happen for last name because they can enter it in either field, and we want to exit out. So make sure when you copy and paste that you make sure you update on those variables. So let's go ahead and give this a run now so that we have this quit option. Okay, so please tell me your name, enter Q at any time to quit. Now I'll enter Q, and now I'm exited out with the break statement. Next we'll look at passing a list. But before we go on to passing a list, let's look at the lab. Okay, so 8-7 album. Write a function called makeAlbum that builds a dictionary describing a music album. The function should take an artist name and an album title, and it should return a dictionary containing these two pieces of information. Use the function to make 3 dictionaries representing different albums. Print each return value to show that the dictionaries are storing the album information correctly. Use none to add an optional parameter to makeAlbum that allows you to store the number of songs on an album. If the calling line includes a value for the number of songs, add the value to the album's dictionary. Make at least one new function call that includes the number of songs on an album. Okay, so it says that we need 3 dictionaries, so that means we need 3 calls to this function that are going to create those 3 separate dictionaries. So looking at our example in Sublime, we could come back right to person.py and use this as an example. Okay, passing a list, the next section. When you pass a list to a function, the function gets direct access to the contents of the list. So here we have usernames, 3 items, Hannah, Ty, and Margot, and that's going to be stored inside of names. So let's go ahead and look at this example. Greet users. So we have a for statement that will go ahead and run through our list. So Hannah, Ty, and Margot stored in names, and then we're going to use a for to iterate through each item in the list. So no return statement in this one, just a general. We're going to call greet users, we're going to send along a list, and then use a for structure to iterate through the list. Modifying a list in a function. Functions can modify the values of the list. Any changes made to the list inside the function's body are permanent. Okay? So printing models, there's 2 examples. One on the bottom of page 143, continuing on the top of page 144, and then there's another example, a modified one of that on the bottom of page 144. So we'll look at how we're going to chunk our code in printing models into functions. Right? So this is the code that's on page 143 and 144. Much like how we practiced in chapter 7, we're going to take what we have currently in unprinted designs and we're going to pop it off of that list and add it to the completed models list. So this example should be very familiar to you with chapter 7. So let's go ahead and give this a run. We have printing model. Here's our current design. We start at the very back, we pop that off, and then it's robot pendant, iPhone case, and then that's how completed models has been built. So from the back to the front if you're looking at that list. So we're going to modify this to be chunked in functions. Okay, so the first function is going to handle the printing of the designs, and the second will summarize the prints that have already been made. Okay, so these are the ones that have already been made, and these are the ones that are handling the printing of the designs. So we're going to create a function here called def print models, excuse me. And models is going to have 2 parameters, unprinted designs and completed models. Then we have our docstring. So again, our docstring is describing what the function does. So some of these comments we can go ahead and just move this up in here. So I'm going to just move up simulated printing each design until none are left, and then on the next line continues our docstring. So move each, actually we're going to do it this way. Move each design to completed models after printing, and then on the next line I'm going to end by docstring. So with that said, I have to indent everything to make this part of the function body. So always indent 1 when you're creating a brand new function of current code. Okay, so while unprinted designs, current design, if you want you can go ahead and remove this comment, that's fine. And then we're going to go ahead and create a second function for this chunk of statements. So show completed models. And this one just has one parameter, or one parameter. And again, doing my docstring. And then indenting my lines. So the bulk of the code is what we call the body. So I'm going to go ahead and move these lines, leaving pushing my functions to the top. And then I'm going to add these, and then I got to call these two functions. So print models is my first function there on line 1, and I'm going to send along unprinted designs along with completed models. So that's my first function call. Then my second one is the show completed models, and we know that that one only has one argument, and that's completed models. So unprinted designs, which is our list with our 3 items in it, is going to be stored in unprinted designs, so sending a list. Right? And then completed models, which happens to be our empty list. So same functionality, just chunking it into sections, so the code is a lot more readable. And again, if we had to call these functions or this code more than one time, we can go ahead and call the function multiple times. So let's give this a run. I get the same exact results, but again, just chunking out that code in a much more readable way. And we've seen this through Alien Invasion and how we've seen these functions chunked. Now don't confuse this. See how the function definitions are on the left margin? Most of ours in Alien Invasion are one indent in because they're part of a class, and that class is the leftmost margin. And we'll be talking about classes in an upcoming chapter, and I think that's actually chapter 9. Now we have this scenario of what if we don't want our function to permanently modify our list. We can use slice notation to make this happen. So that modification would be on page 146, where we would add in, so for example, if we didn't want our unprinted designs to be modified, when we call print models, we would add in the syntax colon, and we learned that in an earlier chapter 2 when we wanted to work with a copy, okay? And so that's the syntax you would use. Now caution on that, simply because most of the time we do want to modify the contents of lists, and actually creating copies of lists eats up memory. And so if you have a special circumstance, of course use it, but otherwise not needed to create copies. Okay, last lab for this section is 8-10, and that's sending messages. Start with a copy of your program from exercise 8-9. Write a function. Okay, so let's jump up to 8-9. Make a list containing a series of short text messages. Pass a list to a function called show messages, which prints each text message. So again, use this example of printing models, okay? Or we can jump back to greet users, where we have this passing the list to the function. Okay, start with a copy of your program. Okay, that's 8-10. Write a function called send messages that prints each text message and moves each message to a new list called sent messages as it's printed. After calling the function, print both of your lists to make sure the messages were moved correctly. So printing underscore models is a great example for your 8-10, which again is built from 8-9. If you have any questions on this section or any of the labs, please let me know.